Hello. Today I'm going to go ahead and showcase to you guys my little instrument preamplifier that I have made. I started this project back in May of 2025 and finished roughly in August. And since then, I've been kind of making little tweaks here and there to like potentiometer values. And well, I'm going to have to do a third revision of the PCB just because I'm getting some noise here, just specifically at the output. And I have a feeling I know why. That's because I have some traces routed too close together with not enough grounding vias around it. I'll showcase that later. I will also showcase a sound demo at the very end so you guys can hear it for yourselves. So let's go ahead and start at the input here. We have our potentiometer here that sets our gain going into the circuit. And then we have a buffer. This is our first gain stage here. And I'm using a JFET, specifically a J201, to do that for us, giving us roughly a gain of 10 volts per volt. That's output voltage to input voltage. Yeah, this is my first time ever working with a depletion mode FET style transistor. I've only ever worked with enhancement modes because of, well, school had me working solely with enhancement mode MOSFETs. But yeah, nonetheless, let's go ahead and show you what that looks like. Here in the red is our input signal, and here in the blue is our voltage after this gain stage here at this node. It is inverted because it is an N channel style JFET. After that, we have another buffer, and that goes into our filter section. So we have a mid, bass, and treble filter. They're all relatively the same, as you can see here, just they have different values in them and whatnot. So I'm just going to go ahead and dive into the mid select, and that should make you clear of what is happening in the bass and treble as well. So here in the mid select, we have three functions. We have the gain that we can adjust, either boosting or cutting. We have a Q factor, which allows us to tighten or widen our bandwidth. And then we have a dual pot potentiometer, RV6A and RV6B here. And that is essentially controlling the frequency select between 150 hertz and 3.6 kilohertz. So let's go ahead and show you what's happening here. I'll do a little AC analysis. So right now I'm boosting a little bit of the mid frequency, as you can see here. For the bass, I have it hard stuck at 80 hertz, and for the treble, I have it stuck at 5 kilohertz, which is another thing I'm going to change because it's just too high for bass guitars. But essentially, yeah, we have some gain here, so let's go ahead and show that we can get some cut with it. So let's change it down from 20% to like 10%. And see that we also have some cut here. We can have a Q adjust here for our mid frequency. All the way up is very wide, so let's bring it back down to say half, 0.5, and see how much we can tighten that up. Very cool. And then we can also change our dual potentiometer here to a different frequency. Let's say, I don't know, 20K. And we have to change both because it is dual pot potentiometer. Cool. And as you can see, the frequency moved and slid over. So yeah, that's that. The bass and treble also have boost and cut, but they don't have a Q adjust, nor do they have a frequency adjust. I've just kind of hard setted that. And yeah, finally, after all of that, we are going into inverting op amp here. Yeah, this is our clean output volume. So let's go ahead and showcase what the output looks like here. So we have the feedback resistor set to about 23% of 50K. And so that's giving us some little gain here. We're now larger than our first gain stage, but that's just a comparison between the input and output. As you can see, it's relatively clean. We have pretty perfect sinusoidal waves here. It is starting to clip just a little bit. As you can see, maybe I turn it up to half. Maybe we'll start to see some clipping then, because the gain stage is turned up all the way. Yeah, you can see that we're starting to get some signal clipping a little bit, round off here. So yeah, let's go ahead, dive into some sound tests of this. Here we go. Here's a little showcase of my pedal. All right. I'm just going to run through all the knobs and show you a little sound test. So first off, we'll set the gain all the way up. This is my dry signal. So let's go ahead, turn it on, and turn up the volume, adjust accordingly. That's about volume matched. All right, let's run through the EQ now. We got a mid frequency, right? This chooses to boost and or cut. Frequency select for the mid, and then as well as a Q factor to shape how much we are cutting the bandwidth or how much we are boosting bandwidth. So I'll go ahead, make the Q as wide as possible, the frequency as low as possible. I'll turn the mid up. You can hear those low mids getting boosted, and as we go up, you can hear the mid kind of open up a little bit. I'll turn that down a little bit and show that works. The bass is about 80 hertz here. You can hear it really drastically get cut and really boosted all the way up. Right in the middle is fine. I should mention that this mid, again, travels between about 350 hertz to about 3.6 kilohertz. So that's all the way about 3.6-ish. Oh, sorry. It's about 3.6. Cool. And then treble. Very high frequency that I selected. I think I chose about 5K-ish. So it's really just air, as you can hear, all the way down. It darkens up, but all the way up. You can hear it. Cool. Yep. So that's the pedal, and yeah, just gonna play around with it a little bit more. So. Okay, now time to showcase the noisiness of this volume knob here. So gain, I'm going to turn down a little bit, and then volume all the way up. You can hear that noise. Just noisy, noisy. So here's what I think the problem is with the noise. These three traces here deals with our very output signal. This top trace here that's highlighted is essentially our signal going into that op amp. Here's C23 and R47. If we go back to that figure here, C23, R47, so that's our signal going into the inverting terminal of our op amp. And our potentiometers here, setting our feedback resistor value, as well as our output here. And that's being sent all the way back, very close, almost touching that trace. And that signal's inverted to this one. This one's inverted from this. And then that gets sent to this switch, which connects to this here and goes to our output, which I'm afraid that these three being too close without having any sort of grounding in between and ground vias is causing some noise